Nitrogen Parameters Company, situated in Chennai, India, is the manufacturer and international supplier of Leaf Color Chart or LCC since 2002. Certified by International Rice Research Institute IRRI Philippines. The company has also been collaborated and certified by different Indian Council of Agricultural Research ICAR institutes and universities for calibrating LCC.
The basic concept is to maintain the threshold chlorophyll content. And we have this chlorophyll meter, we generally call it SPAD meter, developed by Minolta camera. So this is the perfect digital instrument that can help us to know the chlorophyll content of the leaves. So it gives a digital reading. It has very strong correlation with the chlorophyll content in the plant leaves. So it gives readings like 34, 35, 39, 54, 60, and the range is from 0 to 99. And so it is known as, it's the unitless value and is known as the chlorophyll index, not the real chlorophyll value, because we are not analyzing the samples. It is just giving the chlorophyll index, but it has very strong correlation with real chlorophyll content. So this is the basic instrument used in many developed countries to manage nitrogen as per need of the plant. So, but it costs about 2 lakh. So it is highly expensive and marginal, or you can say poor farmers in Southeast Asia, they cannot use it. We started working that how we can use this technology by avoiding this expensive instrument. Then we started calibrating this LCC with the chlorophyll meter. So finally we developed these colors. Sometimes we see it is just the color strips, but it is not just the color strip. It has strong correlation with the readings of this chlorophyll meter. So we translated in the way we are working in the Cambridge India network for translational research. So this is the translational research that translated the digital information from SPAT to leaf color chart using this color strip. So this is the science behind that. When we are using the leaf color chart, we are actually maintaining the chlorophyll content of the leaves to the threshold level. And for that, we have to go for the basic research. When we, first we identify the which leaf is the real index of the demand for nitrogen.
Okay.
And then we establish the threshold leaf greenness or threshold chlorophyll content. Actually, first we establish threshold chlorophyll content, and then again we translate that in the leaf color chart that this is the exact leaf greenness that shall be maintained to achieve the potential yield. So this is the science behind the leaf color chart, that we have translated the digital scientific information from the chlorophyll meter to this simple leaf color chart.
And in which crops this leaf color chart can be used?
So by now we have recommended PAU leaf color chart in rice, then maize, then wheat, now in cotton also. And in rice, for the transplanted rice, it was earlier recommended, and we have now also given the recommendations for the direct seeded rice and basmati rice.
Dr. Vinderpal, throw some light on the methodology to use leaf color chart in different crops.
Yeah, the methodology to use leaf color chart is very simple tool, and it can be easily used in the farmer friendly technology. So what the farmers have to do when they are managing site specific nitrogen management in rice, after the transplanting of the rice, we recommend to apply 25 kg urea per acre immediately after the planting. And after that, after 15 days, we recommend to measure the leaf color greenness of the rice leaves with the step number 4.
Yeah.
And whenever the leaf greenness is below step 4, we recommend to apply 25 kg urea per acre.
Yeah.
So starting from the 15 days after transplanting till the initiation of flowering, we measure the color of the first fully exposed leaf from the top under body shade with the step number 4, and whenever the color of the rice leaf is below 4, we recommend to apply 25 kg urea per acre. So there are few precautions that farmers shall always keep in mind, that whenever we use leaf color chart, we have to measure the color of the appropriate leaf. We call it index leaf. So the leaf is not same in all the crops. For the rice crop, for the wheat crop, it is the first fully exposed top leaf. And it can be easily distinguished that which one leaf is the first fully exposed. And in case of maize, it is again the first fully exposed top leaf. But sometimes the farmers get confused in maize, because in maize, the top 2 or 3 leaves, they just round around the stem. So we have to take the first top leaf that has the well developed collars. So we measure the color of the first fully exposed top leaf in rice, maize and wheat. But in case of cotton, it is not the first fully exposed leaf, because in cotton all the leaves are exposed, even the just newly born leaf. So in case of cotton, we do not take the first fully exposed leaf, but we measure the greenness of the first fully developed leaf. So it may be second, third or fourth, that could be easily identified. We do not use the newly born leaves, we use the leaves those have been properly developed. So after having the knowledge of which leaf we shall take for measuring leaf greenness, the next step is to have in mind that we shall always measure the leaf greenness under body shape. Now the next point is how to use and what step shall we use in rice, wheat, maize
different
and
crops.
cotton. This is most important. So in case of rice, we use the step number 4. In case of maize, we use a step number 5. So methodology in case of maize is almost same as that of rice, because in rice we also apply 25 kg urea per acre. In maize we also apply 25 kg urea per acre. But in case of maize, the threshold leaf greenness is 5. Whenever the leaf greenness comes below 5, we recommend to apply 25 kg urea per acre. In case of rice, we start after 15 days of transplanting and we go up to initiation of flowering. In case of maize, we start after 21 days of sowing and keep measuring the color till the initiation of the silking at 10 days interval. In rice, we measure color at 7 days interval, and in maize, we measure color at 10 days interval. So this is the way we can use it in rice and maize. In case of wheat, the recommendation is to apply diammonium phosphate at the rate of 55 kg per acre if our soils are medium fertility soils.
As basal dose.
As basal dose, 55 kg DAP per acre. And we can change this dose as per soil test. If the soil test recommends to apply phosphorus more, we apply more, otherwise we apply less as per soil test. So the basal dose of phosphorus shall be given as per soil test, and we need not to apply any urea at the time of planting. So after plant, at the time of first irrigation, we recommend to apply 40 kg urea per acre without the use of leaf color chart, because at first irrigation the wheat leaves, they are very small and they cannot guide us the real need of the plant for nitrogen. So the first dose, the fixed dose, we apply 40 kg urea per acre with first irrigation, and then at the time of second irrigation, that comes generally after 50 to 55 days after sowing, we go for leaf greenness measurement, and always we measure the leaf color of at least 10 leaves in an acre. And if the leaf greenness is more than step number 5, we recommend to apply only 15 kg urea per acre. And if the color is below 5 but above 4.5, we recommend to apply 30 kg urea per acre. And when the leaf color comes even below 4.5, more than 4 and in between 4.4 and 4.5, we recommend to apply 40 kg urea per acre. So if the color goes even below 4, then the recommendation is to apply 55 kg urea per acre in wheat. So this is the way how we manage nitrogen. So in case of wheat, if our color is even more than step number 5, we apply only 15 kg. So 40 at the first irrigation, 15 at the second irrigation, that comes out to be only 55 kg urea per acre. So the farmers can achieve the potential yield of the wheat even with the use of the 55 kg urea per acre if the leaf color greenness is more than 5. So this is the way we recommend to use this leaf color chart in wheat. And the last in cotton. In case of cotton, at the time of planting, we need not to apply any urea. So we measure the leaf color greenness at two growth stages. The first is the thinning. After planting of the wheat, after about 3 or 4 weeks, we go for the thinning of the cotton with the first irrigation. And at that time, we measure the leaf greenness. And in case of cotton, it is like wheat, not like rice and maize. Because in rice and maize, we have one threshold. In rice, the threshold is 4. In maize, the threshold is 5. But in case of cotton, we have a variable threshold like wheat. And if the reading is more than color 4.5, we need not to apply any urea in cotton at both the stages. And if the reading is below 4.5 and more than 4, then we recommend to apply 20 kg urea per acre. And when the color further goes down, it is more than 3.5 but less than 4, we recommend to apply 35 kg urea per acre. And when it further goes below 3.5 or comes equal to 3.5, we recommend to apply 50 kg urea per acre in cotton. So this is the way we can use it in rice, wheat, maize and cotton, all the major field crops.
You will agree with me that the cost benefit analysis of the technologies is very, very important. What monetary benefits are expected to be accrued from this technology?
And Dr. Nishatar Singh ji, when we talk about the economic benefits from this technology, I will say it's a win-win technology. It has all benefits. I can say it is a foolproof technology because this is the technology that always ensures the potential yield. So the purpose of the technology is to help farmers to achieve the potential, the maximum yield he can have. It's not the tool to reduce the nitrogen use. It's the tool to ensure the optimum use so that we can achieve the potential yield. So if I talk about this village, as per the statements of the head of this village, the Sarpanch, and as per the successful farmers, Rinder Prakashi and Mahinder Singh, what they told us? They told us your farmers saved from 50 kg to
105 kg.
105 kg urea per acre. So the farmers in the village, they saved from 50 kg to 105 kg urea per acre. I am not coming to the lower limit, I am just going below the lower limit. So lower limit here is the saving of the 50 kg urea per acre. If I assume the saving of only 25 kg urea per acre in rice, wheat, maize and cotton in Punjab, then it will lead to saving of 2.5 billion only in the Punjab state of India of the farmers. And the government would also save the 5 billion because the government has subsidized urea by 2/3. So the 2/3 price of the urea is given by the government. So ultimately in Punjab state of India, we can achieve the saving of 7.5 billion every year. So you can assume that if we go talk about the whole India, if we talk about the global scale, we will have the huge saving of the nitrogen. So this is the calculation based only upon the saving of urea. And the farmers and the head of the village, they told us that they have also saved at least one spray of insecticides. And as per Rinder Prakash, the cost for one spray of insecticide is about 1500 to 1600.
Yes, sir.
So saving of 1500 rupees per acre, you can count if we are having the saving of about 280 rupees for urea and the saving goes up to 2.5 billion and they are also saving rupees 1500 per acre, the saving will, you can say, the saving would be multiplied by at least 6 times. So this is the, you can see the benefit of this very small, simple and highly efficient gadget that saves 2.5 billion of the farmer, 5 billion of the government. excluding the saving from the insecticide and pesticide. So
Dr. Virendra, whether any institution or a scientist submits the projects to the funding agencies, they inquire about the environmental concerns of that project so that the technologies developed from that project are not environmental hazardous. So accordingly, how this technology is helpful in checking environmental pollution.
this technology is being appreciated across the globe only because of the environmental concerns. When we use the nitrogen in excess, the excess nitrogen goes out of the soil plant system either in the gaseous form or it goes down as leaching. The nitrogen that escape out of the soil plant system, the atmosphere through denitrification, it leads to the release of nitrous oxide. And you know the global warming potential of the nitrous oxide is 298 times that of carbon dioxide. So we plug the losses of the nitrogen from the soil plant system to the atmosphere as nitrous oxide, that is the has a direct impact on the global warming. So using leaf color chart, it mitigates the global warming potential. So secondly, when we apply nitrogen excess, it goes down through leaching. If I talk about Punjab, as per the available data, in 60s, the nitrate content of the water was only 0.5 milligram per liter. And now the average nitrate content of the Punjab water is 5 milligram per liter. And there is the increase of 10 times, tenfold increase in the nitrate content of drinking water. So when we are using more and more urea, more and more nitrogen fertilizers, they are either going to the atmosphere or they are going down the drinking water. So it mitigates the pollution of the underground water as well as our environment. So you can see, besides the benefits of saving nitrogen, beside the benefits of saving insecticide and pesticides, this technology helps to conserve nature by reducing the pollution of the air as well as the drinking water.
Dr. Virendra, what is the future of this technology? Is it going to enhance the crop basket where we can use this technology?
That future of the technology is very bright. Dr. Singh, I was in Cambridge working with the researchers in the National Institute of Agricultural Botany and University of Cambridge in the last 5 months. And actually we are working in a Sinton project, already know, Cambridge, India.
That DBT project.
The DBT sponsored project in India, and from the different funding agencies in UK, India and UK government has a collaborative research project. And the objective is to reduce the escape of nitrogen from soil plant system to atmosphere. We discussed the science behind the development of this PAU leaf color chart. Ultimately, they found this PAU LCC as the most efficient and economical tool that can help achieve maximum nitrogen use efficiency while sustaining the yields. And finally, they have written to our worthy Vice Chancellor that they want to transfer this technology of the PAU leaf color chart from India to UK for the UK crops. So you can see the future of this two simple gadget. They are looking for the economical technology. They are looking for the technology where we can have the more cost benefit ratio. So this tool, PAU leaf color chart, is a tool that helps to achieve the high cost benefit ratio.
And that too at no cost.
That too at no
cost.
They can save lot of money, because in the developed country it's not like India. The government is not giving 2/3 subsidy. The nitrogen is expensive, fertilizer are expensive, and there is no subsidy from the government side, and the farmers have to pay the full cost of urea. So the farmers, I interacted with the farmers, the researchers in different at different platforms in UK, and not only the researchers, the farmers, they were also interested to use this PAU leaf color chart. So I believe it has a very bright future, and in the times to come, the PAU LCC, this leaf color chart technology would be the one of the most important technologies to ensure site-specific and need-based nitrogen management in different field crops.
Dr. Vendrapal, you have covered almost all the points about the use of this technology, the benefits of this technology, the adoption of this technology, environmental benefits of this technology. The last point which comes to my mind is that how and from where the farmers can get this technology, get this leaf color chart. As the technology has spread to other states also, the farmers of other states, they can also make benefit of this technology. PAU has signed a MOU with Nitrogen Parameters Chennai for the manufacture of this leaf color charts. The website of that organization is www.nitrogenparameters.com. Telephone numbers can contact 98-842-22269. The other telephone number is 444-264-9313. Can dial these numbers and get the information and can purchase the leaf color charts from this organization, which is Nitrogen Parameters based at Chennai. Thank you very much.